Okay, we're going to look at the second part of this last calculus question. And here we go. 10.2. What are they asking here? What are they asking? They're asking for the coordinates of A. They're asking for the coordinates of A. I can tell from the memo they're asking for the coordinates of A. And they say, okay, so what is A here? Well, it looks like Y is 0. That's called an x-intercept. We should let Y equal 0. We could factor out x squared, and we see x is equal to 0 is one solution, but the other one, minus 6 plus 6 is 0. So, hey, x must be 6. Well, that's pretty good. You could have factored a little bit differently, but you still get that x equals 6 is a solution there that makes y 0. So A is 6 and 0. Now let me go back and take a look at what the question is here. Whoops, I don't have the question here. But you have the question and you're looking at it. And I think they say, I remember the question now, looking at the answer. Isn't that interesting? You'll say, the question is, for which values of x is this function increasing? For which values is it increasing? Well, I'm going to use a little demonstrating vertical line to do that. You see, if I take a little vertical dotted red line here and I pass it through, you can see the places where it's increasing. You see, as I go along here, its x is getting smaller and smaller and smaller and smaller. Now it's 0. Right after 0, it starts to get bigger and bigger and bigger and bigger and bigger. And there it hits its maximum. So it's increasing between 0 and 4. Or if I thought of tangent lines, the gradients are positive. There are positive tangent lines. If I push them up against here, it's 0 here and 0 here. The gradients are positive going through there. And as I go from left to right, I can see I'm getting bigger and bigger. So that's why it's increasing. The values of x where it's increasing is x is less than 4, but greater than 0. And that's how you have to write it. Calculate the coordinates of A. Oh, that was the question 10.2. They're asking for A, and I've already explained how we do that. We let y equal 0. So we've done 10.2. I couldn't see it on my screen here. Okay, write down the values for which it's increasing. Oh, there's the questions. How could I not see it? You could see it. You probably wondered, what is he doing? Okay, that's where it's increasing. And where is it concave down? Well, this is an interesting thing here, you know. You could take the derivative and then take the derivative again, and that's called the second derivative, and make it equal 0, and you'll find that x equals 2 would solve that. That's the point of inflection. But they don't give many marks here. So what they're saying, the point of inflection here, it's symmetric. Between the two turning points, 0 plus 4 divided by 2, 2 is the place where it's called the inflection point, where it changes from concave up to concave down. So the question is, where is it concave down? Anywhere greater than 2, where x is greater than 2. To the right of this 2, that's the point of inflection, where it changes from a cup into a hat, where it changes from concave down concave up to concave down. That's called the point of inflection. And it's always right in the middle, in between the turning points in a cubic equation there. Well, it isn't this one, anyways. Okay, the last question is a little bit tricky. I'm saving a separate video for it because it really makes you think.